Hey everyone, and welcome back to the channel. Today, we're going on an epic journey across our cosmic neighborhood to explore the incredible diversity of planets right here in our solar system. You might think you know them all, but there's so much more to these worlds than just their names. From scorching hot rocks to massive, swirling gas giants and even tiny, icy wanderers, let's dive into the different types of planets that call our solar system home. First up, let's talk about the inner circle, the planets closest to the Sun. These are the terrestrial planets, also known as the rocky planets. The word terrestrial literally means Earth-like, and for good reason. These for planets Mercury, Venus, Earth, and Mars are all relatively small and dense, with solid, rocky surfaces you could theoretically walk on. Well, if you could survive the extreme conditions, that is. Let's start with Mercury, the smallest of the main planets and the closest to the Sun. It's a world of extremes. During its long day, temperatures can soar to over 800 degrees Fahrenheit, hot enough to melt lead. But at night, with almost no atmosphere to trap heat, it plummets to a bone-chilling minus 290 degrees Fahrenheit. Its surface is heavily cratered, a lot like our moon, telling a story of billions of years of impacts from asteroids and comets. Next, we have Venus, often called Earth's sister planet because of its similar size and composition. But that's where the similarities end. Venus is a toxic inferno, shrouded in a thick, crushing atmosphere of carbon dioxide and clouds of sulfuric acid. This atmosphere creates a runaway greenhouse effect, making Venus the hottest planet in the solar system, with surface temperatures consistently around 900 degrees Fahrenheit. It's hotter than Mercury, even though it's farther from the Sun. The pressure on its surface is over 90 times that of Earth's equivalent to being nearly a kilometer deep in the ocean. Then, of course, there's our home, Earth. We are the Goldilocks of the terrestrial planets, not too hot, not too cold. Our unique position, combined with a protective atmosphere and the presence of liquid water, has allowed for the flourishing of life. We have a dynamic surface with continents, oceans, volcanoes, and an active climate system. We are the only rocky planet with a large moon, which stabilizes our axial tilt and gives us predictable seasons. It's a special place, and it's the standard by which we measure all other potentially habitable worlds. The last of the rocky planets is Mars, the famous red planet. Mars gets its reddish hue from iron oxide, or rust, on its surface. It's much colder and has a very thin atmosphere, mostly made of carbon dioxide. But what makes Mars so fascinating is the evidence that it was once much warmer and wetter. We see dried up riverbeds, deltas, and lake beds. We've even found water ice at its poles and underground. This has made Mars a prime target in the search for past or even present microbial life. With rovers like Perseverance and Curiosity exploring its surface, we're learning more about its ancient history every day. So that's the inner solar system, for small, dense, rocky worlds, each with its own unique and dramatic story. But now, let's travel beyond the asteroid belt, a vast region of space rocks separating the inner and outer planets. Here, the rules change completely. Welcome to the realm of the giants. The outer solar system is home to the gas giants and the ice giants. These planets are enormous, and unlike the terrestrial planets, they don't have a solid surface. They are mostly composed of gases and liquids swirling around a small, rocky core. First, we meet the king of the planets, Jupiter. Jupiter is simply massive. It's more than twice as massive as all the other planets in the solar system combined. If Jupiter were a hollow ball, you could fit all the other planets inside it. It's a gas giant primarily made of hydrogen and helium, the same elements that make up the Sun. Its famous colorful bands and swirls are actually cold, windy clouds of ammonia and water. And, of course, there's the Great Red Spot, a gigantic storm larger than Earth that has been raging for hundreds of years. Jupiter also has its own mini-solar system of moons at last count, over 90 of them, including the 4 large Galilean moons, Io, Europa, Ganymede, and Callisto. Next in line is the jewel of the solar system, Saturn. While Saturn is another gas giant, also made mostly of hydrogen and helium, it's famous for its breathtaking rings. These rings aren't solid, they're made of billions of small chunks of ice and rock, ranging in size from grains of sand to house-sized boulders. While other giant planets have rings, none are as spectacular or complex as Saturn's. Like Jupiter, Saturn is a world of fast winds and massive storms. It's the least dense planet in the solar system, so light, in fact, that it would float in a bathtub if you could find one big enough. Saturn also has a fascinating collection of moons, including Titan, which has a thick atmosphere and lakes of liquid methane and ethane on its surface. Now, we journey even farther out to the mysterious and frigid ice giants. These planets are different from the gas giants. While they also have hydrogen and helium, their atmospheres contain a higher proportion of ices, compounds like water, methane, and ammonia. Uranus is the first ice giant we encounter. It's a strange and chilly world. What makes Uranus truly unique is its extreme axial tilt. It's tipped over on its side, rotating at a nearly 98-degree angle to its orbit. This means it essentially rolls around the sun on its side, leading to bizarre seasons where one pole gets 42 years of continuous sunlight, followed by 42 years of darkness. This odd tilt might be the result of a massive collision with an Earth-sized object early in its history. The methane in its upper atmosphere absorbs red light, giving Uranus its pale blue-green color. Finally, we reach Neptune, the last of the major planets. Neptune is a dark, cold, and incredibly windy world. It holds the record for the fastest winds in the solar system, with gusts whipping around the planet at over 1,200 miles per hour. Like Uranus, its blue color comes from methane in its atmosphere, but Neptune's vibrant, deep blue suggests there might be another unknown component as well. One of its most famous features was the Great Dark Spot, a huge storm system similar to Jupiter's Great Red Spot, though it has since disappeared. Neptune has several faint rings and a collection of moons, the largest of which, Triton, is a geologically active world that orbits Neptune backward. But wait, our journey isn't over yet. There's one more category of planets we need to talk about, the dwarf planets. These are celestial bodies that are big enough to be rounded by their own gravity, but they haven't cleared their orbital neighborhood of other debris. The most famous dwarf planet is, of course, Pluto. For over 70 years, we knew Pluto as the 9th planet. But as we discovered more objects in the outer solar system, like Eris, which is about the same size as Pluto, astronomers had to reconsider the definition of a planet. In 2006, the International Astronomical Union created the dwarf planet category, and Pluto became its most famous member. The New Horizons mission in 2015 gave us our first close-up look at Pluto, revealing a stunningly complex and active world with vast nitrogen ice plains, towering water ice mountains, and a thin, hazy atmosphere. Besides Pluto, there are several other recognized dwarf planets, including Eris, Haumea, and Makemake in the distant Kuiper Belt, and Ceres, the largest object in the asteroid belt. Ceres is unique because it's the only dwarf planet in the inner solar system. These small worlds show us that the line between a planet and a smaller body isn't always clear-cut, and there's a huge amount of diversity out there. So, from the small, fiery, rocky planets to the colossal gas and ice giants, and finally to the small, icy dwarf planets on the fringes of our system, our solar system is a place of incredible variety. Each planet is a unique world with its own history, composition, and secrets waiting to be uncovered. Understanding these different types of planets helps us piece together the story of how our solar system formed and evolved over billions of years. Thanks so much for joining me on this tour of the planets. What's your favorite type of planet and why? Let me know down in the comments. If you enjoyed this video and want to explore more cosmic wonders with me, don't forget to hit that like button and subscribe to the channel. See you in the next video.